Hello everyone, Mr. Hisner here. Today I will be the rabbit that leads you down into Wonderland and looks deeper into the maze that are circles. And today we're going to be looking at what are called inscribed angles. Now these inscribed angles are super easy to see. And inside an inscribed angle is an angle formed by all points on the circle. So for this one, right, we have these two chords. Inscribed angles are formed by these two chords, and the So this angle ABC, what do we want to find? Well, if we want to find this arc measure, this inscribed angle, this arc measure AC. Let me do some highlighter. Yeah, that looks better. Remember that it would be a central angle. If we want to find AC, this is going to be simply 1/2 the measure of ABC. Really nothing to it. This is just half of the arc measure. Very, very easy concept to grasp. All right, but we do have some other stuff. We have the intercepting. We have what happens when the chord intercepts a diameter. That means what happens when it goes through the diameter. Well, if we have a chord, right, we have our one chord, and then our other chord is the diameter. When one of the two chords is the diameter, we do form a right angle. That means that there is a right angle formed. So this angle BAC is a right angle. And overlapping arcs, what we have here, overlapping arcs, what we see here when we have, like, okay, here's this one. Okay, here's this one. What we see here is that the two inscribed angles intercept the same arc. Then these arcs will be congruent. So angle ABD, an angle will be congruent to angle ACD. So these two in the corner will be the same. But what happens, long story short, is these are basically similar triangles, because all three of these angles will end up being similar, will end up being congruent because these two angles are vertical angles. And so what we'll have here is these are actually going to be similar triangles, which is super fun, and I'm sure all of us are not tired of doing stuff like that. All right, so let's look. Let's see what the measure of angle JKL is. JKL. Well, here we have what, 50, 53, 65. Now we have a new magic number, 360. So what do I have here? Well, I have 53 over here. We got KL over there, 65. We want to find this one. So I'm just going to subtract the two parts from the whole thing. That is 360. So I'm just going to subtract the two parts from the whole. That is 360, and this is 242. And so if I want to find the inscribed angle, so what we had found before JKL was that what we discussed previously was that our inscribed angle is half of the arc measure. And so the whole thing is 242. So this one's going to be half of 242, which is 121. 121. Let's see what happens if we throw some algebra in here. Let me just see if I can find a good one to do. How about we do this one? Just arbitrarily chosen. So here we go. We have 92. So we got this piece out here, 92. We got this piece over here, 162. And we want to find, we can kind of find this one. So I'm just going to go ahead and find that. 360 minus 92 minus 162. And this is 106er. And so now we can see, okay, well, these angles are not equal, but instead they're half. And so 7x minus 10 will be equal to half of 60, 102. So the 7x minus 10 is equal to 53. 7x is equal to 63. X is equal to, ta-da, 9. So again, this idea that we have to use angles again, we're subtracting from 360 most often. Don't forget to look for vertical angles. Linear pairs are also always going to be here as well. So here we have some notes we need to remember, but overall, the overall arching theme from this is that we have halves. We have halves for our relationship. All right, guys, thanks for watching.